Okay, this is the second part of doing the main loop. This is where I describe to you how to do this bit. The equation now time is larger than last drop time plus drop delay. Then set last drop time equal to now time, and that allows it to continue the piece to drop one row of blocks continuously down the screen until something happens. Okay, so I've actually drawn this out for you just to explain it better. Okay, so I should maybe open this in Paint. Sorry, I'll make it easier to show you. Okay, so initially what happens is the piece appears. Okay, so we draw the current piece. The piece appears at the top of the screen. Okay, so what happens here is when we get the last drop time in milliseconds from the clock. This is, say the time is 4:15 PM and 3 seconds, or nearly 4 seconds. Okay, so that's that. So that's 4 PM, 3 and almost 4 seconds, 3 seconds and 9,256 milliseconds. Okay, and it's the milliseconds that we're interested in. So that's the last drop time. Okay, so last drop time is here. So let's just use this as an example. It's 4:15 PM and almost 4 seconds past. Okay, and we know our drop speed is 735 milliseconds. So the last drop time is 900 and, what did we say, 900 and, it's this time 9265. Okay, 9265. Okay, as the program runs, it will take 2 milliseconds, approximately 1 or 2 milliseconds, maybe 3, for it to go all the way through the program. Okay, so when we set the last drop time to the now time, it will have about a couple of 2 or 3 milliseconds will have expired. Okay, so the now time will be, if we set the last drop time equal to the now time, it will actually be just a couple of milliseconds in advance. Okay, because it takes a couple of milliseconds for the computer to go through the program. Okay, so that's why it's 927 and not 9265. Okay, and we set our drop delay for the current level, which will only increase as the levels increase. Okay, but for this it remains constant, and it's at we set it at 735 milliseconds. Therefore, we know that if we add the last drop time here and the drop delay, it will be significantly larger, or a lot larger, a lot bigger than the now time. Okay, remember the now time is approximately equal to the last drop time. Okay, it's approximately, it's actually, the now time is just slightly larger. Okay, because it has to have time to run through the program. Okay, so the last drop time is the same here, as you can see. Oops. Okay, so last drop time, obviously it remains the same. Okay, and so does the drop delay, remains the same constantly. When the piece is, this is just before the piece is about to drop. Okay, so you can see if you add 0735 to 9265, you get 16:15:04. Okay, so we have, in this situation here, part 2, we have the last drop time just before the piece is about to drop. We have the last drop time. If you add the last drop time and the drop delay together, it's still just larger than the now time. Okay? And obviously the now time is a lot larger than, or a lot bigger than, the last drop time. Okay? So we have the last drop time, and the if you add the last drop time and the drop delay, it's larger than the now time, but only just. Okay? So that's that situation just before it's about to drop. Just after it's about to drop, just here, okay, sorry, sensitive mouse, okay, just here, you can see, and you can see here, this is a couple of milliseconds later, okay, obviously the last drop time is still constant, it's still the same, and the drop delay as well, still the same for the current level. Okay, so the last drop time plus the drop delay is now less than the now time. So that's the last drop time plus the drop delay is now less than the now time. Okay? And obviously the now time is still significantly larger, or a lot larger than the last drop time. But this is the equation that we need. Okay? This one here. So I'll just put that in red. Okay? Okay, we can write this: now time is larger than drop delay plus last drop time. It's just easier. We can put this on the other side. This is exactly the same as writing now time is larger than last drop time plus drop delay. Okay, that's exactly the same thing. Okay, so that's exactly the equation. Oops, is exactly the equation that we need. Okay, and that's where our equation comes from. Okay, now it might seem a little strange as you go 1, 2, 3, and it's starting to drop, and then it goes back a bit. Okay, this is well, it takes a couple of milliseconds to run through the program, and it has to wait until a millisecond after the program. Okay, I'll just repeat that. So it takes a couple of seconds to go through the program, and you have to wait at least 1 millisecond after before this statement here is true. Okay, so it will actually drop a little bit, and then you can reset it. If you set the last drop time equal to the now time, it will reset, which is this bit here. So if you set the last drop time to the now time, it will reset it here. Okay? So I'll just go through that one more time. So here we have the 0001 and the couple of milliseconds here, couple of milliseconds, and a millisecond here. So it actually just starts to drop, and then we set the last drop time to the now time, and it resets. Okay, so it kind of like drops a little bit. You don't really need to worry about that, but that's how to do it. So it'll actually be slightly more than 735. We wanted it 3/4 of a second exactly, and that's why it's 735 and not 750. Okay, because obviously when you update the screen buffers as well, this will take a few milliseconds as well. Okay, and every time it draws it, and when there's more pieces on the screen, just to keep it regular and timed. Okay, so that's where those equations come from. Obviously the other equation being here, last drop time equals now time. Okay, So if now time is larger than the last drop time plus the drop delay, and last drop time equals now time, then if not plays piece, if not drop piece, end of game equals true. So if now time is larger than last drop time plus drop delay, set the last drop time equal to the now time so it continues to drop, and if it can't drop a piece and it can't place a piece, then the end of the game is true. And that's how you get the equations. Okay, I hope that makes some sense. If not, have another look over it, and if you still don't understand it, leave some comments below and I'll try and get back to you. Okay, it's a little tricky when you're not familiar with this, but basically all it is just like timing, like on a stopwatch, and pressing the lap button, etc., etc., and keep on resetting it. Okay, I will see you on the next tutorial, which will go into a quick review, and then we will go into all the functions. Okay, thank you.